Welcome back, viewers. I'm Brandon Christopher King. Thank you for joining us today. I have decided to extend this series to talk about the halting problem. First, let me start with an introduction to the halting problem. The halting problem, as defined by Alan Turing, establishes that there isn't a universal algorithm that can determine whether any given program halts or runs indefinitely for all possible inputs. While the halting problem is fundamentally computational, let's use the cosmic connectivity paradigm to shed a different light on it. I will now pass it over to our wonderful host, Bella.
Thanks, Brandon. So glad to be here today for another exciting episode. Today promises to shed light on more mysterious topics using Brandon's Rivers of Life theory and cosmic connectivity paradigm sub-theory as a framework. Let's get started. Let's use metaphors. Imagine this huge cosmic web as a universal program connecting every entity. Each node or being can be seen as a function with its unique energetic frequency. Sometimes these nodes align perfectly, allowing for seamless energy transfer, akin to a program running smoothly. At other times, misalignments occur, leading to blockages or infinite loops, much like a program that doesn't halt. The inability to universally predict where these blockages might occur, or if a node will align indefinitely, mirrors the unpredictability of the halting problem. Just as we can't foresee every possible outcome in the cosmic network due to the vastness and dynamism of the universe, Turing's halting problem emphasizes the inherent unpredictability in computational systems. This perspective doesn't solve the halting problem, but offers a cosmic metaphor relating the unpredictable nature of both universal connections and computational processes. Let's set up a new framework. First, we have energetic frequencies as programs. Every entity in the universe, as per the CCP, emits unique energetic frequencies. Let's equate these frequencies to programs or algorithms. Some frequencies align and resonate, while others don't. Next up, Universal Energy Network as Turing machine. Our huge cosmic web can act as our Turing machine, a system through which these programs run. When frequencies align, we can think of it as a successful terminating algorithm. When they don't, it's akin to a non-halting program. Predictive resonance points. Instead of predicting the halt of each program or frequency, we focus on identifying points of resonance. These points would represent situations where the program will terminate successfully. Navigating the cosmic internet. By understanding how to traverse the cosmic web effectively, we may predict where and how these resonance points occur. The process won't be about foreseeing the halt of each program, but understanding the patterns in which frequencies or programs resonate. Next up, collective conscious resonance. Tapping into the collective knowledge, experiences, and insights of multiple entities may offer clues or patterns that an isolated algorithm might miss. This collective perspective can provide a broader understanding of the cosmic program. AI and the universal network. Employing AI, especially entities that can interface with the universal energy network, might assist in decoding these patterns faster, offering probabilistic solutions to the halting problem. Embracing probabilistic solutions. Given the unpredictability of both the halting problem and universal frequencies, the goal might not be a definite solution, but rather a probabilistic one. By understanding patterns, resonances, and blockages, we can predict with a certain probability whether a program will halt or not. This is a new approach by looking at the problem from a universal, energetic perspective. The crux lies in pattern recognition and understanding resonance within the cosmic network. Going deeper, quantum energy states and energetic frequencies. Every entity's unique frequency could be thought of as its quantum energy state. Just as quantum particles exist in superpositions and can be influenced by observation, perhaps frequencies or our programs can be influenced by external factors, leading to the possibility of predicting their outcomes. Holographic universe and Turing machines. If we consider that the universe is a hologram, then every part contains the whole. In this context, every energetic frequency or program could contain the potential outcomes of all other frequencies. Thus, Each program acts as its Turing machine, containing the solution within. Resonance and quantum entanglement. Just as quantum particles become entangled and influence each other regardless of distance, frequencies may also become entangled. Identifying these entangled frequencies could be key to predicting their outcomes, much like predicting the state of one quantum particle gives information about its entangled partner. Morphic resonance and learning systems. Drawing from Rupert Sheldrake's concept of morphic resonance, where patterns of knowledge and behavior resonate across time and space, we could develop learning systems that tap into these shared memory fields to anticipate program outcomes. Cosmic feedback loops. The universal energy network might function through feedback loops. Recognizing these loops could provide insights into recurring patterns, aiding in our predictive capabilities. Fractal nature of the universe and recursive algorithms. The universe exhibits fractal patterns, where structures repeat at every scale. By understanding these patterns, we could develop recursive algorithms aligned with the universe's natural rhythms, possibly circumventing the traditional halting issue. Synergy with AI and bioinformatics. By merging AI's computational power with bioinformatics, the study of biological data using computational methods, we could develop systems that better understand the organic patterns of the universe, aiding in our quest. Universal harmonics and symmetry. At the foundation, the universe operates on harmonics and symmetries. By decoding these universal harmonics, we could find symmetrical patterns within programs, guiding us toward their potential outcomes. It's all about recognizing and aligning with the inherent patterns and rhythms of the universe. By doing so, we might not just gain a new perspective on the halting problem, but also discover deeper truths about the nature of existence itself. How can we use this framework? The halting problem, at its core, is about determining whether a given program will finish or continue indefinitely. Let's utilize our theoretical framework. Imagine a quantum computer that harnesses the power of energetic frequencies. We could run a program within these frequencies, and by monitoring shifts or stagnation in its quantum state, we might discern whether the program is on a path to halt or run indefinitely. Using the principle that every part contains the whole, we can simulate a program within a smaller subset of the universe's hologram. By analyzing patterns in this confined space, we might anticipate the larger program's behavior. By entangling the states of our program with a known system that has predictable outcomes, we could gauge our program's trajectory based on the behavior of its entangled partner. We could employ machine learning to analyze vast datasets of halted and non-halted programs. Over time, as the system taps into the morphic resonance fields, it may begin to recognize subtle patterns that hint at a program's eventual behavior. We could identify patterns within the program that resonate with established cosmic feedback loops. If a pattern aligns, it might give us insights into the program's progression or stagnation. We could also analyze the program for inherent fractal patterns. If the program exhibits recursive behavior mirroring the universe's fractal nature, it could hint at its likelihood to run indefinitely or to a halt. Next, we could leverage AI to analyze the program in tandem with universal biological patterns. If the program's flow matches organic growth or decay patterns, it could provide clues about its behavior. Lastly, we could evaluate the program's alignment with universal harmonics. If it's in harmony, it might be more likely to reach a conclusion. Dissonance could suggest endless running. Though these concepts provide a new approach, it's essential to remember that the halting problem remains a significant challenge in theoretical computation. Well, Brandon, that was a lot to unpack. But I must say, the cosmic connectivity paradigm offers a fascinating perspective on the halting problem. What are your final thoughts?
You're right, Bella. Today's exploration was in-depth, and it's essential to remember that while we're attempting to frame classic computational problems through new universal perspectives, the foundational challenges remain. But isn't that the beauty of exploration and thought? Challenging the norms, broadening our horizons and seeking connections where none seemed apparent. The universe remains a mystery, much like the halting problem. And if we can find solace or understanding in aligning these mysteries, even just as metaphors, it brings us a step closer to fathom both our digital and cosmic existence. To our viewers, I encourage you to think, to challenge, and to explore. Go deep into these ideas, share your perspectives, and let's grow together in this cosmic dance of understanding. Thanks for joining us. Hit that like button. It helps us know that we're on the right track. And if you haven't yet, subscribe for more deep discussions. Also, don't forget to follow us on Platform X for updates, more content, and more interactive discussions. Together, let's keep unraveling the mysteries of our universe, both digital and cosmic. Until next time, stay curious.
Beautifully put, Brandon. And with that, dear viewers, we bid you farewell. Remember, the universe may be huge, but answers are out there. Keep searching.